Hello everyone. Let us solve problem T of Codeforces Educational Round 100. In this problem, you are given an array of size n. For our example, we will take n as 5. And we are given some array, and the elements of this array will belong to 1 to 2n, and all the elements will be distinct. Now, what are the elements of the range 1 till 2n is missing in this given array? So n elements will be missing, right? So 1 is already here, 2 is missing, 3 is missing, 4 is here, 5 is here, 6 is missing, 7 is missing, 8 is missing, 9 and 10 are already there, right? I will copy paste this. I will use this later for further explanation. Okay. So we want to do something for every x, for x equal to 0, for x equal to 1 till x equal to n. In our case, till x equal to 5, right? Okay. For example, let us take x equal to 3. So we'll pick first 3 elements of P. This x equal to 3. If it is 4, we'll pick first 4 elements of P, right? Yeah. So this is one grouping, first 3 element, and the last remaining element is second group, right? Yeah. Now we have to pair these elements of B with the element of A, and we have to make sure that if we are pairing with this group, the first group, this curly braces group, so if you want to pair 6 with 4, yes, it is, we can pair this because 4 is less than 6. If this element is less than 6, less than this element, then only we will pair, right? Similarly, we can pair 7 with 1. Yeah, because 1 is less than 7, right? But if you want to pair something in this second group, right, in that case, this element should be smaller. For example, I can pair 8 with 10 because 10 is bigger than 8, right? Similarly, I can pair 3 with 9. 9 is bigger than 3, and this is second group. And you can pair 2 with 5, right? If you pair 2 with 5, 2 is smaller than 5, right? Which is incorrect, because if it is coming to first group, that element should be bigger than the element over here, right? So the mapping that we have done right now, this is not acceptable, right? Let us try to do it in some other way. Okay, 7 to 1, 6 to 5, or 8 to 4, right? Here 1 is less than 7, 4 is less than 8, 5 is less than 6, so it is valid. Similarly, 2 to 10, 10 is greater than 2, 9 is greater than 3. Yeah, so all the conditions hold. So we can see for x equal to 3, that pairing is possible, so that it is accepted. So for x equal to 3, it is possible. So the question is, for how many x it is possible? This is what we have to find. For how many x we can pair in this way. Okay. Let us look at one observation now. Observation is, if I have to pair, say x equal to 3, right? Then what we can do, pick the last element from this array A that we have created, right? And map it one by one. 6 with 1, 7 is 4, and 8 with 5. Pick, similarly pick this remaining two element from here and remaining two element from here and map it one by one. 2 with map with 9 and 3 will map with 10, right? And that check, is this mapping correct? 1 is less than 6, correct. 4 is less than 7, yeah. 5 is less than 10, correct. 9 is greater than 2 because this is in second group, it should be greater. Similarly 10 is greater than 3, right? So this is, yeah, this is right, as you can see, and it is enough to check in this manner, right? It is possible that some other pairing will also work, but if some other pairing is working, it is for sure that this way will also work. Let us understand why. So here we are picking first three element, last three element, okay. So here what we want a bigger element to come here, right? We want bigger element to come here and a smaller element to come in this region, so that this element will be greater than the smaller one, right? So if you want bigger element to come in this region, so what will you do? You will pick all the greater number and send it here in this region, right? Similarly, if you want a smaller element to come here, so which one uh, will you prefer? A smaller element, obviously you will pick from the starting all the smaller element and you will send this in this region, right? That's the idea. Okay, let us look at one more observation, and later on we will use all the observation to solve the problem. Next observation is this. So now say again we have chosen x equal to 3, right? Now we know we will compare with last three element of this, right? And these two with these two, but I'm not looking at these part right now. I'm just looking at beginning of p and the end of this, only that part, whether that is satisfied or not, right? But the question is, we have to check for both. We have to check for this part as well and this part as well. If both are satisfied, then only we'll say this is accepted. But for now we will check only the first part of this and last part of this, okay. So the observation is, I will explain using some generic array. A, this is B, and we have picked some element x here and x element here, right? Say for this x, it is not satisfying the acceptance. It means this element over here is bigger than the element over here, right? If this is B, this is A, right? And if this is not satisfying with this, so there is at least one element where this is true. B is greater than A instead of B is less than A. That's why this is not accepted, right? Okay. Now, if for x, so for a given x, if it is not accepted, so now for every x, every bigger x, x plus 1, x plus 2, whatever, it will still not be accepted. Because, so say if we want to increase the size of x, so what we will do, we will add one element, right? So here we will have one more element, and here also we will have one more element. Now, so previously we were comparing b with a, right? Now since one more element has been added here, and the comparison will start from this position. So now this b will be compared with some element before a, one element before a. Now b is greater than a, okay, and this array capital A is already sorted, if you see above here, in sorted order, right? So it means this element is smaller than a. Let me write here a dash. Now a dash is smaller than a, right? And we know that b is greater than a. So it says b is greater than a dash as well. And since b is greater than a dash, it means x plus 1 is also not accepted, right? Okay. So the takeaway from this is, if for some x, the first x and the last x, it is not accepted, all the other x, bigger x, will not be accepted. Yeah. Okay. Now we'll store this information, or we can represent this information like this. So this is x equal to 0, x equal to 1, x equal to 2, x equal to 3, 4 and 5, right? Okay. For x equal to 1, let us populate it is accepted or not. For x equal to 1, what you will do, you look at 1 here and 8 here, right? 1 here, 8 here. 1 is less than 8. Only one check was there, accepted. For 2, so here I have first two element here and first two element here, and we'll compare 1 with 7. 1 is less than 7, yes. 4 is less than 8, yes. So both holds, accepted. Now we have 3, x equal to 3. So first 3 of this, last 3 of this, compare. 1 is less than 6, 4 is less than 7, 5 is less than 2, 8, accepted. Now one more element, 1 less than 3, yes. 4 less than 6, yes. 5 less than 7, yes. 9 is not less than 8, right? So it is not accepted. Now similarly, without looking into this array, I can say that if it is, this one is not accepted, all the bigger x will not be accepted, right? X equal to 0 means that you are not taking anything from here, from starting nothing, from similarly from ending nothing. Okay, so this is, you can say, you don't have to compare, or you can say it is accepted, right? Because since there is no element here, no element here, so we can, this is accepted, right? Okay. Now we have looked for the starting part, starting of this and ending of this, right? Now the other part is pending, ending of this, right, and starting of this. So we have looked at x, right? Now we look at n minus x. Let me write here. Now here we have b and we have a. Now we'll look at not x. Now we'll independently look at n minus x. N minus x from end, and in a, n minus x from beginning. And similarly, we can find out this kind of array, right? So let me, I will draw one more array here. Now we have n minus x. So n minus 4, right? So n minus x here will be, so when x is 0, n minus x will be n. it will be, or for our case n is 5, so I'll write here 5. 5 minus 1, 4, 3, 2, 1, 0, right? Okay. Now what it says, it here 0. 0 means no element from the end, no element from the start. Okay, let me copy this over here. Okay. Now we are looking for the n minus x part. So n minus x is 0. It means we are not looking anything over here and not looking anything over here, right? In that case, there is a match. Now n minus x is 1. So look at one element here and here. Now 10 is greater. Now we'll check for greater because we are talking about n minus x, not x, right? So if you look in this bigger array, this part is x, n minus x, this is x, n minus x. So we are talking about n minus x. So if n minus x is 1, so one element from end and one element from beginning, and we look for greater match. 10 is greater than 2, yeah, matching. Now if n minus x is 2, so 2 elements from end, 2 elements from beginning. 9 is greater than 2, yes. 10 is greater than 3, yes. So yes, matching. Now 3 elements from end, 3 from beginning. 5 greater than 2, yes, yes, yes. One more. 4 greater than 2, 5 greater than 3, yes. Now let us take everything. 1 greater than 2, no, 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 not accepted. Okay. Now we have populated independently, right? Independently looking at only this, right? This one, right? This one only looking at this and this part, right? Similarly, we have populated this looking at n minus x part, right? Now when can we say that some particular x is valid? Now some particular, for our original question, right? Original question, particular x is valid. So it is valid when x is valid and n minus x is also valid, when both are valid, right? So basically we have to look at how many places both are valid, right? If you see here, it is valid. At this place, this one is valid, this one is not valid. We will not take this one. Here also both are valid. So for this and here, one is valid, one is not valid, not valid. So one for x equal to 1, x equal to 2, and x equal to 3, it is valid. So for this, answer will be 3. Yeah, this is the second example from the question, this one that I have explained here. Okay. Now we'll look at the implementation now. So first we'll look at how to get this array A, right? Because we are given this array B, from this we can easily obtain A. So this will be step number 1, right? Second step, in the second step we will find this while using the first of B and the last of A, part of A, first part of B and last part of A, till how, from 0 till how, what place it is true, right? Then in the third step we will find from and till how many places it is true, right? Like 0 to 3 it is true, from this is true from 0, in n minus x value is from 0 to 4, or if you talk about the index is from this is index is from 1 to 4, right? This is 1 to 4. This is third step. And then finally fourth step is how much intersection is there. This is our fourth step. So this 1 2 3 4. Okay. Now first step we'll talk when we will look at the code. For the second part, if you observe in the second part or notice that these are continuously true, then I mean accepted for continuous value of x, right? And after this it is not accepted. So here we can use, in these two scenarios we can use the binary search, right? Binary search to find the endpoint. Like here finding 3 using binary search, here also finding 4 for example, or basically this left endpoint. So left endpoint and right endpoint we can use binary search. Then after this, in the fourth step we have to just take intersection of two segment, right? Here we have two segment, so from this 0 to 3, 0 to 3, and here we have 1 to 4, right? So what is the intersection? Intersection is, sorry, not 0, intersection is 1 2 3, right, between these two segment. And how many elements are there? 3. Okay, now I will open the code and we can discuss then. I'll keep it here for the reference. Okay, now in this we have one input size of array, right? Then here we have created one vector of size 2n plus 1. And why we are doing this? Now we are focusing on part 1, how to find array A and B, right? So we are given, in our case, n as 5. So I will create element from 0, 1 2 3 till index 10, right? 2 into 5 plus 1, which is 11, size 11. Okay, and initially everything is filled with 0. Now I will take the input and take the input and take the number, and in this array I will set that to 1, right? So if you set some value like 1 4 5, okay, whatever you will set to 1, it means it is a part of B, right? And whatever is set to 0, whatever is not set to 1 basically will obviously be part of array A, right? And we can ignore the first one. So yeah, so in the next line you can see we are iterating from index 1 to 2n. Then we are checking if it is 0, it is part of A, right? Else it is part of B. So here we have created our array A and B, right? Now what we want is, now we want to solve this second step. In the second step we want to find this, right, the rightmost point, this 3. So we have a function that we'll discuss, find range, and to this function we are passing A and B and size of the array, right? And it will return me n1. n1 is nothing but this 3, value 3, right? And here we'll discuss what it is. After doing this thing we'll get n2. n2 is this nothing but this 1, index 1, right? And after this we are just printing the answer. Like this is we are checking how many common elements are there, right? Okay, so find range. We'll look at find range, but before that, why for the second scenario, if you look at the second scenario, instead of A and B, we have passed B and A, right? So if you notice here, so in this one, for the first one, for the first scenario, we were looking at first few elements of this, and similarly last few elements of this, right? Similarly, for the second scenario, we are looking at this and this, right? But if I swap these two array, sorry, these two array, right? So even the second one will become same as the first one. So here I was comparing first few with last few, right? Now, and if you see here, first few and last few. So if I swap, the situation will become same, right? So I can take advantage of that and then find this range, right? And adjust this. Why? Because when I will call this function, this find range, it will give me this 4, right? But from 4, what do we want? We want 1, right? Because we want to find the common segment. So this function will return 4, 4, and I will subtract 4 from n, then I will get 1, right? So n2 is 1. Now I have 1, I have 3. I can take the difference of these two and add 1 to get the answer, number of common elements. And 0, the 0 is for the scenario when there is no common segment. For example, say 1 is 0 to 3, right? And next is 5 to 7. So how many elements are common? There is no common elements, right? So if you do 3 minus 5 plus 1, you will get minus 1. So basically, if it is negative, so that's why I'm doing here max, because I know if it is negative, there is no intersection. So if this part will become negative, automatically we'll get 0 as answer, that there is no intersection. Okay, now only part left is this find range. Yeah, find range, you have A, B, right? And you have size of both the array A and B. Now here we are simply doing the binary search, right? So how we are doing? So we have this array A, array B, right? Now binary search we will what will be the answer? I mean, where will be the point? How many elements will come in X, right? It will be either, I mean, where will be the separation? Say separation is here, right? So separation can be from 0 to n minus 1. So we can run a binary search, right? Then we can look at the midpoint of 0 and this low and high, and say this midpoint is pointing here, at some index k. So now what we will do, so we have few elements over here, and we know that we'll few elements over here, then we'll compare one by one, right? So if you look here, we are comparing. If the condition is not satisfied, we'll mark this as false, right? Initially marked as true. Now if it is not satisfied anywhere, mark it as false. Then after the loop ends, we can compare. If the answer is possible, if it is possible, I mean this is valid one, so we can store our answer and update our low value, right? Otherwise, we know that if it is not possible, so there is no need to check for bigger k. So we'll keep highest k minus 1, right? Yeah, I hope you understand this problem. Thank you for watching.